table shown gives values of the function in the first derivative at selected value of x. Let h be the function defined by h of x equals f of g of x. Find h prime of 7.
So they want us to find the derivative. Isn't this a chain rule? Chain rule? Okay, so let's go ahead and write on here. We have h prime of x. Let's recall the chain rule. Which part do we derive first? The very, very outside or the very inside? The very, very outside. And you keep the inside as it is. And then we go in layers, derive the inside. And I'm not going to go back to the table back and forth. You have two sheets in front of you, so I'm expecting you guys to read off of it. It wants us to plug in what for the x? H of what? 7. So let's plug it in. F prime of
0.
G of 7. And then G prime of 7. So let's go in layers. I want you to find x equals 7. What is G of 7? 0. So we have F prime of 0. And then what about what about the G prime at 7? 8. And then we go into F of 0. F prime of 0, I mean. It is what? Good. So we have 3 over 2 times 8. And if we simplify that, the best way to do this is dividing this first. What is 8 divided by 2? 4. 4 times 3? 12. So here's a breakdown. Knowing how to derive using chain rule, all that, is going to give you 1 point. That was so fast.
I know, we have no life. So we
Thank you so much. And then your final answer, 1 point. So here's my question to you. Could I have stopped right here?
Yeah.
In case we make silly mistakes? You can. For any free response, as long as you plug everything back in, you don't have to compute all the way. Okay? So hopefully you guys are saying yes, yes. Okay? Question?
So if you get the answer wrong, but you have that right, they count it wrong?
No. I mean, if let's say you write on here, I don't know, 11, they're not going to go back and check for you. So if that is wrong, then they're not going to go back. So you won't get that 1 point. But you might get the derivative though. Okay? Let's go on to part B. Okay, for part B, Kylie, go ahead and read.
Let k be a differentiable function such that k prime of x is equal to f of x squared times g of x. Is the graph of k concave up or concave down at the point where x equals 4? Give a reason for your answer.
Hopefully by now you have the PVA card like just floating around in the air, right? Or if you close your eye, that's all you see. Okay, so concavity happens when f double prime is what? It's up.
It's changing signs.
So not concavity, my bad. So if f double prime is positive, is concave up. Do we all see that? Okay, and it's concave down if it is negative. So I'm gonna put on here if f double prime is negative, and then concave down if f double prime, ooh, I said it wrong, concave up is positive. Having a moment. So we have to go ahead and derive the function. So let's write the function already on the top so we have something to refer back to. So this is given from your number 5. It says f of x, all squared times g of x. And I'm going to double check it's given. Yep. So that's already our first derivative. I need to derive this just one more time, okay? So we have k double prime. So keep in mind, this one, when we're deriving, it's going to be chain rule. And this one will be as it is. So our rule for product rule is we derive the first one, keep the second one, and vice versa, right? What operation separated this? Addition, very good. So when I'm deriving this, 2 comes down. We keep the inside as it is. And then derive that inside. Times the second one we leave alone. Plus, now we keep the first. When I derive the g of x, it's simply g prime of x. It's a prime, by the way. And what number did the question ask us to plug in?
4.
4. So let's plug it in. Woo, that was long. Okay, let's see what parts I want you to read off the chart. Okay, I'm gonna leave the 2 alone. What's on f of 4? 4. What is on f prime of 4? Very good. What's on g of 4? Perfect. Plus. What is on f of 4 again? 4. So I'm gonna write 4 all squared. And then the last one, is it 2? Okay, let's multiply these in chunks. I will take these 2. So the first one is going to be 8 times negative 9. How many is 8 times negative 9? Negative 72. And then what about 16 times 2? Ooh, 36. Oh, no. 32. That's okay. So we know this one is going to be less than 0, right? So you don't have to go on any further. If it bothers you, go ahead and put negative 40. So then we want to go ahead and write this in sentence. So K is concave up or down? Because the double prime is what? Very good. Concave down at x equals 4. Write more than you need. Because K double prime of 4 is less than 0. If you want to say it is negative, that's okay. If you want to say it is negative 40, that is also okay. So our point breakdown. Knowing how to derive, it's going to give you 1 point. Hopefully that's going to be a yes for you, potential. And then also plugging it all in to get the negative value. And again, you don't have to have negative 40. Okay? That inequality alone is good enough. That's another point. And of course, writing it as a sentence with the x value and the reasoning is another point. And I really hope you guys are saying potential, potential, potential. Okay? Let's go on to part C. For part C, we're going to use fundamental theorem of calculus. And in case you forgot, I'm going to show you the card. At some point, this is going to happen, and we're going to apply this. Okay? So let's see. Where's my... Oh, here it is. Jocelyn, go ahead and read part C, please.
Let m be the function defined by m of x equals integral. Find m of 2, show the work that leads to your answer.
Okay, so let's start by writing out the equation on the top somewhere. So they gave us m of x. C and D is very similar with just one tiny difference. And it could be a common mistake, so I'm going to go back and forth when I get to D. So 5x squared plus, this is given, integral from 0 to x of f prime of t, that's a 0, dt. And they want us to plug in what? Plug in 2, okay. So we have m of 2. So we have 5 times 2 all squared. So then, imagine this. What's that? Oh, is it cubed? Oh no, where's my original? Let me double check. Okay, cubed. That is a sad day. Who caught it? Good job. Okay, so for this one, I'm gonna apply my card. And imagine x is my 2. So if I were to apply this, the way I'm gonna translate it is f of 2 minus what? F of 0. So we have, let's just put on here f of t from 0 to 2. So here's the idea on this one. When I integrate and I derive, aren't they opposites of each other? Okay? Integrate and deriving are opposite. They cancel. That's why f of t is by itself now. Okay? So then when I further plug in, that will be 40 times 5, which is how many? Not 40 times 5. That was the answer. 5 times 8, right? Silly me. Now I'm going to put this in a bracket just because. F of 2 minus f of 0. So now, if you were to have applied the fundamental theorem of calculus and you skipped this portion, it is okay. Because y'all can go from here to here. Okay? That is okay. I'm just making a detail. I don't know why. So we have 40 plus. Now look at your chart. What's that f of 2? 7 minus, what is that, f of 0? 10. And then we further go on, we have 40 minus 3, which is 37. So my points, this one's a little stingy. All that work, 1 point. Because really in the end, you're plugging things in. So I'm gonna write out the equation, original equation over here first, to kind of describe why something is gonna happen. That's a cubed. So we have 0 to x, f prime of t, dt. So my last one, Joe, go ahead and read the last one.
Is the function m defined in part C increasing, decreasing, or neither x equals 2? Justify your answer.
Okay, so when something is increasing, that means my slope is positive. If it is decreasing, my slope is negative. So I have to find the slope. And by the slope, I mean the derivative. So when I derive this, let's write out m prime of x. Okay, let's see the difference. A while ago, we took the 2 and just directly substituted in. We didn't do any operation, right? This time, we have to actually derive it, and that's going to matter on the second part. The derivative of 5x cubed is 15x what? Squared. So now, when I derived the integral of that derivative, I can only cancel out one integral and one derivative, correct? So that means I really in the end have f prime of t dt. Again, I'm going to repeat myself one more time. If I derive, I said derive once, right? The integral of the derivative, only one of each cancels. That's why the derivative here is still there. Good? So then, oh, dt has to be gone. What am I thinking? You know. Okay, so let's go ahead and plug in what number it says? 2. So we have 15 times 2 all squared plus f prime of 2. And again, it's just a matter of looking at the table for the second piece. For the first piece, that's going to give us 4 times 15, which is 60. What's that f prime of 2? Negative 8. That's going to give us 52. So then we want to go ahead and justify. M is, so this is positive, right? Increasing at x equals 2 because m prime of 2 is positive. So our point breakdown, knowing how to derive, is going to be 1 point. Finding the positive value is another point. And our justification, last point.